about the diagnosis first. If it is cold, what is the probability of cough being there? Very high. If it is heartburn, what is the probability of cough? Very low. If it is lung cancer, very high again. Okay. So we have got these three things. Okay. So in the above formula, this is, I call it the chances of data. Given the first term, the chances of hypothesis, what is the probability of cold itself in this particular population at this particular time? And now current climate, very high. Heartburn, again the probability is quite not as high as cold, but quite a possibility. And lung cancer, it is actually very rare, fortunately. Okay. So now you put these two things together and you will realize that chances of hypothesis into chances of data is highest in case of cold, and then in case of heartburn the first factor is high but the second is low. In case of lung cancer, the first is low, the second is high. So doctor then arrives at cold. This is the basis of Bayesian method, and this example is taken from a famous paper by a famous researcher, Tenenbaum. The next technique, evolutionary programming, this is however considered to be the key technique that will be used when we talk about the frightening future of AI. So the three principles that are used are mutation, generation and selection. That you take any program, however simple, make small changes and make copies of it with smaller changes, and then apply the problem and select the best. Again, make small changes, make a number of copies. So within a few generations the program actually becomes very capable of solving the given problem. This is a problem that we are actually working on in Survey Labs, the seed classification problem. The seeds of things like wheat, for example, they are of various varieties. Farmers need to classify them in order to select the right thing to sow. This is obviously currently being done by human inspection, but we can actually use AI to do this. We can, what I am showing on the left hand side is a programming technique, image processing. So by image processing, find out the various parameters such as diameter and the color, etc., and put that into a decision tree that will actually give, or use what is called as a neural network, which I show on the right hand side, and we can actually feed pictures, tell the network what this is. Then after a certain number of training samples, the neural network will actually get trained and able to identify right from the picture of the seed. So you can actually carry that program in your mobile and go to the kirana shop and find out whether that basmati and ambe moor is really deep learning, which is what I showed you in the seed classification problem. These are neural networks and they have multiple layers. Each layer learns about a different thing about the image or whatever data you have. The most famous is the system AlphaGo Google owns. This is the system that beat the world Go champion last month. There are a lot of frameworks. TensorFlow is from Google. Caffe is a famous open source. Digit is a framework from, it's a cloud framework from NVIDIA. And deep learning is being used for things like image identification, prediction, natural language processing, of course, one of the earliest areas of AI and still very, very relevant. Basically, NLP deals with text understanding, and it actually also encompasses text generation, though that is many times termed as natural language generation or NLG. It's like translation, summarization, sentiment analysis, which is a very, very upcoming field because of the social media impact. These are all things which are handled by NLP. Number of frameworks are available like GAT and NLTK. Watson, you must be hearing a lot. This is basically a QA system. It's actually a special server, special computer built by IBM for this kind of tasks. It has amazing learning capabilities. It can, like some of those things that you saw in the movies, it can actually read 1 billion books per second, because it's primarily a massive machine. It has got those Power 7 processors, some 3000 of them, 16 GB RAM. So some time back I heard that if you want to have the minimum requirement for Watson you want to use for your company, then it will cost $1 million. API is available. Lots of people are actually using it to build various kind of AI applications. One of the first areas to be applied was healthcare, where it is being used for research in cancer, etc. Analytics of various types. Education is also one area where another important area that we'll read about is hardware. Now, deep learning is resource hungry. It requires massive computing power. So, for example, when we tried to train a neural network, put it onto a laptop, and we gave it some 100 images, then the time required to train was some 4,000 days. Resource hungry thing, and suitable hardware is now coming to the market. You have parallel processing architectures like Hadoop, Amazon, Azure, they all have their machine learning capabilities which you can utilize on the fly. GPU has become a very important factor in this. Earlier used primarily by the game enthusiasts, but GPU is turning out to be a game changer in the whole machine learning. Special chips, processors are coming up like TPU from Google, and companies like Nvidia are leading. Intel is also coming up with a special AI chip. The prominent application areas where primarily the next important jobs and businesses will be created. The first, of course, is robotics. Yeah, robotics has been there since the very beginning, because the very first projects were like for creating artificial soldiers. Philip to research in robotics, but what has changed today is that thanks to our sister technology IoT, big advances have been made in sensors and actuators. So the biggest factor in robotics is the cost. Then they have to be offered at a cost that everyone can afford, and that is where these advances are coming handy. We have special AI chips now, and the new AI techniques that are used in vision and speech and processing. So robots are going to become much more common than they are today. Don't forget that drone is also a robot, and the self-driving car is also a robot. So, but there are other things like cobots, which are primarily robots that you use as your assistant. Analytics has already become big, but the current most of the big data tools that we use today are still based on the rules and decision trees, and but now all these new machine learning and NLP statistical methods are being used more and more. So you are all familiar with analytics, I suppose. The recommendation engines, prediction is a big area. Anomaly, which I find is good, which I think is going to be bigger in the time to come, because IoT, when you have lots of sensors put into something, then you actually would require an anomaly processor to detect problems. Or process automation is where the fear of losing jobs primarily is being displayed into all areas like accounting, legal, where those complex legal documents are programs, media, where news stories are being written, simplistic ones today, but things like reports, the results of a company and summarizing it, those kinds of things are already. I don't know about whether AI is going to destroy more jobs or create, because while it is destroying jobs on one side, the other side, a lot of jobs are being created, but those jobs will be primarily into areas which relate to AI. Take software, for example. AI will change the way programming is done and primarily test, because once AI gets into software, the whole process of testing, software engineering is supposed to undergo a change. So more jobs will be created on that side. This has already become big. The chatbots, it is being called today, but actually it's the virtual private assistants is the application area. This is supposed to be the replacement of apps, because everybody understands that how many apps people are going to install on their phones. So if you have some one program which will understand and do everything for you. This will revolutionize customer service, things like the orders that we place, booking lists that we do, and it can even run helplines for people in distress. Just want to talk about few of the startups that. The first one is DeepMind. The reason why it is first is because this probably is the startup which started the rush. It was in January 2016 that DeepMind was acquired by Google for some 500 million or so. DeepMind was a British startup. So DeepMind, the DeepMind system learns how to play games, and it uses the deep learning neural network. Google bought this, and today the AlphaGo system is basically the advancement of the technology of DeepMind, and Demis is still very much there leading that. SwiftKey is another interesting example. SwiftKey basically is a intelligent keyboard that you can even use in your Android. DeepMind was actually trying to create a platform on which we can build AI applications, and it was being used in collaboration with, if I am not mistaken, UCSF for cancer related research, but now it has been acquired by Salesforce, and I think they are no longer public. Numenta is a interesting case. They have a technology called HTM, hierarchical temporal memory, which basically tries to mimic the way our cortex works. Cortex is the part of the brain that does all the thinking and reasoning. Numenta has actually released a framework which in fact we have used and tested in our company that can do prediction and anomaly. OpenAI is not a startup really. It's actually an initiative from Elon Musk. Okay, but it gives me a chance to talk about the perceived threat of AI, which people like Stephen Hawking and Bill Gates and Elon Musk are mentioning, that AI might become a danger to humanity in the time to come. So OpenAI is an initiative to actually keep that in check, so that more and more the AI research becomes open. It is easier for us to monitor and make sure that it doesn't. So everybody is demanding for what is called as the kill switch now. So we should be able to kill AI when we think that it is, before it is too late. Okay, with a few words about my company. I founded this company in 2014. It's a research company in artificial intelligence. Our areas of interest are machine learning, NLP and information extraction. Our current work is on image classification and on assistants, or the form is chatbot. We also recently we have started with the consulting and training wing. We offer internships and project fellowships. Internship is for a short research kind of work. Project fellowship is primarily for the duration of a project. Two people who are enthusiastic, they need not have prior knowledge in AI. Thank you so much for listening.